Okay, so very good morning, good afternoon, good evening, everyone. So my name is Pankaj Gupta, and I'm here to welcome you all again in the third day of the SWAT workshop by today's speaker. Our guest is Sushant Mehanji. Sushant is very special to us because he's associated with the SIAHI from since the first day, and in behind all these the event organized by the SIAHI. So, in a brief, Sushant is a PhD in agriculture sciences engineering, and nowadays our research associate over there in US, and also the vice chair of the young professional community of American Society of Agriculture and Biological Engineers, that is ASABE. So without taking much time, I would like to request Dr. Susanji to take care of the today's sessions, and I will be there in the background to help you if any questions. So over to you, Susanji. Thank you.
Thank you, Pankaj, for such kind words. But it's all you and a lot of other members involved with SIAHI who do a great job, and I'm happy to contribute in whatever way I can. Without further delays, so we have this 2-hour breakup into 3 different sections today. Before I get into the 3 sections, for those who have joined late, so I have put a Google Drive link in the chat box. So I would appreciate if you guys can go to that Google Drive link and can access the material for today's workshop. So how the material of today's workshop should look like in the drive, it should be something like these 3 different items in that Google Drive. For now, the first section of this 2 hours, we will be talking about the uncertainty in the hydrologic modeling, just 20 minutes, small theoretical component. And then rest of the time of this workshop, we will be having hands-on practice on SWAT-CUP. So by that time, I would appreciate if you can get the software downloaded, but I will have everything from the scratch. At least just download this zip file or this folder. Uh, okay. So I hope everybody can see my screen as well.
Yes, we can see you.
Awesome. Yeah, I'm having 2 different monitors, so pardon me if I'm not right now concentrating on the screen itself, but please put your questions in the chat box, and as soon as we will have some break, I'll try to address most of your questions. And the end of this presentation, I would have my email address as well, in case if I'm not able to answer your questions in the session today, I would be happy to get in touch with you guys via email. Okay, so good morning all again. Today I will talk about a very interesting and the most, I think, very important topic, which is uncertainty in the hydrologic modeling. So let's first break up this phrase. Just a second, guys. So let's first break up this phrase. What we have got in this phrase is the uncertainty, which is something that can be defined as the amount of the variation in the numerical difference from the observed information, or I should say complete determinism. For example, you go to a field day and you want to measure a water temperature of a particular creek or a river or a lake, and you find that your lake temperature is 4.2 degrees Celsius, give or take, plus give or take 0.2 degrees Celsius. So what do you mean by give or take? So give or take is actually is defining us that the water temperature of that particular creek that you went for that you went to and observe the water temperature could be actually smaller or larger than what you have measured, and that level of uncertainty was zero point 0.2 degrees Celsius. So when you do any kind of modeling, not only hydrologic modeling, any kind of modeling, it becomes completely useless if you are not quantifying the um, uncertainty in the model. Just a second. That's a disadvantage. Okay. Sorry for the technical challenges. Just give me a few seconds. Okay. And the second word in the phrase is the hydrologic. We have studied for a very long time. Logic is the study. Hydro is the study of water, water sciences. And third word in this particular phrase is the modeling. And so modeling, consider it like to be a movie, consider it like to be any song with characters, with actors that represent a kind of a phenomena. So what we are going to talk about, the play or the phenomena today, would be a hydrologic cycle. And what we are going to talk about today in this particular show would be who are the actors, who are the characters, what is the sequence, how this movie is written in the hydrologic sequences, and where the errors start propagating and how we can stop those errors. So moving forward, the first thing that we are going to talk today is characters in the modeling. So a typical modeling study involves 4 different types of actors. The water managers. They can be a person or a group of people, an organization responsible for management or protection of the water resources, and thus of the modeling study. And of course, the outcomes also. So second is the modeler, any person or an organization that develops the model and works at conducting the modeling study is basically the modeler. Third are the auditors or the reviewers, a person or an organization that is conducting some kind of external review on what the modelers have developed. And lastly, they are the stakeholders, civilians, or the public. Any interested party is that has a stake in that modeling and water management issue is basically a stakeholder or the public. While learning these terms, question must be popping into your mind who all are, means we all are the water managers, or we are modelers, we are auditors or reviewers. So you have to give the way to yourself, because at times you're auditors, most of the time you're modelers, sometimes you are civilians, means I should say all of the time we are civilians, because what we are doing is going to impact us or our families. So these things define your research question, which I was emphasizing in the last week also. So for what particular research question you are trying to address or use the use the soil and water assessment tool is something that you need to be very careful about. Moving forward, in the last slide, we talked about the model characters. Now let's talk about the sequences, how the movie in the hydrologic modeling takes place. So in the step 1, it's a planning phase or the model study plan, which is comprising of different questions. That why is modeling required for the study? What is the overall modeling approach? And which work should be carried out? Who will be doing the modeling work? Who should be doing the technical reviews? And which stakeholders to include or involve, or to what degrees? What are the different resources for the project? So all these questions has to be designed first before putting your step into the model itself. Likewise, there were some questions last week on the lake evaporation, on the lake dynamics, or on modeling the lake. So what exactly are you looking for in the lake? What outcomes are you expecting out of those lake modeling? Who will be using those results? So questions like that are very, very important before setting up any kind of a model. Once you have those questions answered, who is responsible for what, you have division of labor now, then it moves to the step 2. In this step of data and conceptualization, the modeler should gather all the possible information necessary for setting up the model, for checking up the model, and step-by-step evaluation, or I should say, it should be a step series where you should keep on evaluating your model as you are moving forward towards your modeling exercise. So that can only be done if you have the maximum information about your watershed or your study area, and that can come only through data. Data is not something like hard figures. Like you don't need to have I should say, the complete daily time series of evapotranspiration throughout the growing time season. No, even if you have aggregated information, or even if you have the rough estimate from the extension studies or people who are experts in the discipline, they have some kind of information that can inform you whether your model is making right decisions or not. So that is also kind of a data. So collect as much information as possible. I remember from the last week, somebody was talking about the irrigation aspect. So if you are interested in irrigation aspect, for which particular crop, what type of irrigation, on and off, variable irrigation, or it's a continuous irrigation system, what kind of system it is. So such kind of information is important. And third step is, this step implies to the processing of the data. So I can give you a time series of the information of your rainfall and temperature of your particular watershed. Would that be important for you? Maybe not. So you may need to process that information. So in step 3, it's all about model setup, processing information, and executing the model. So step 4, at this stage, we usually analyze the model outputs. We first check with our knowledge that was available from the step 2 and assess how much it is away from the reality. Once we know that it is away from the reality, we try to do some kind of calibration and calibration at our own front. Like, for example, if we know that the surface runoff in the urban area should be higher, and we have very low curve numbers out there in our watershed. So that is the first red flag, and we can fix it on our own. But in a watershed model like SWAT, which has more than 400 parameters, and there are 3 or 4 different research questions you are trying to answer, it becomes sometimes difficult to go back and check which particular parameters would be affecting your result, until and unless you have really become that thorough with the parameters or the algorithm behind what is governing that process, that you can go back and make changes to those parameters. So, and last is the step 5, depending on the objectives of the study, the simulations from the model can be used for decision making, whether I should go in for um, irrigating variably in that particular field, or I should be continuously putting the water out there. Should I have water availability based on soil moisture or something else? How should I be determining about my consumptive use? So a lot of questions can be answered if we have the modeling study structured in these 5 different phases. Moving forward, now question comes up about the uncertainty. So uncertainty comprises of the 3 different dimensions, at least that I know, could be more, but from my experience, it comes from 3 different dimensions. The location, where the uncertainty manifests itself within the model complex. So if you have a system, if you want to, taking an example from the last week exercise, if you want to model reservoir and you don't know the stream flow at the upstream or the downstream end, and you're not modeling those outlets, and you want to have the outcome from the reservoir within, and you're not putting the variables inside, parameters to simulate that reservoir. So that is where your models start getting building up the uncertainty point. So the second is the level of the uncertainty is the second dimension I consider, where the uncertainty manifests itself along the spectrum between absolute and I should say absolute deterministic thing and the total ignorance. So either I don't know anything or I am looking for the complete reality from the model. Both the two extreme cases are a bit off. And in this range, there is some kind of uncertainty that can happen. I cannot address all the questions about limnology. I'm not a limnologist, but I can just tell you the way to how to work on a kind of a reservoir or a river, but maybe there are various processes which I will not be aware of that must need to be simulated to answer the questions that you're looking for. Likewise, just a small example would be SWAT uses qual to E, which is very simplistic version of the in-stream processes, and it is dependent on only 6 different calibration parameters for phosphorus, and I think 4 or 5 for nitrogen. Are they enough? Maybe not. Maybe yes, depends on how much critical answers are you planning for. So that is where this level of uncertain level dimension comes up. And third is the nature of the uncertainty, whether the uncertainty is due to kind of any imperfection of our knowledge, as I was talking about, or it's due to inherent variability of the phenomena being described. For example, the biggest challenge with the SWOT is if you run SWOT at the daily time step, it uses SCS curve number method. The green amped is just possible with the sub-daily information, but green amped is much more robust when it comes down to erosion part, infiltration part, but is it feasible to run a watershed of 20,000 kilometers square at the sub-daily time step and run green amped? So a lot of questions come in, but that is where the processes, parameters, your knowledge, everything comes in and uncertainty aggravates. Next is location of uncertainty. Should be characterized in a way that it is operationally beneficial to understanding where in the model and uncertainty associated with the outcome is generated. The bullets out here on the slides are some generic locations. Context refers to the conditions and the circumstances that underline the choice of the boundaries of the system, framing any kind of an issue or formulation of the problems. For example, in SWOT, the soil temperature right now is simulated using just normal empirical equations, but it becomes quite critical in, I think, cold region hydrology when your soil temperature really plays an important role. And at that moment, empirical equations may or may not be that robust. Do we need to introduce numerical solutions to it? Do we need to include the some kind of derivative function or complex mathematics to make that process dynamic in nature? So that is where this context comes in picture. And the second is the model uncertainty is due to either model structure or model technicality. In this process, I would say you cannot have everything simulated with what you can answer a number of questions, but you have to prioritize your question that my primary focus is to address hydrology for now, or am I using it for water quality now, or I want to use it for what kind of question I'm trying to address. That it becomes an important thing when it becomes to the location of uncertainty. That is where this model structure comes in, whether I want to go for green amped, whether I want to go for SCS curve number, model technicality. Do I need to build in more dynamic parameters for in-stream processes? Or right now the qual2 is not modeling benthic organisms at the bottom of the river. Is it fine if I don't model them? So something like those things become your model uncertainty. Then input uncertainty is something that we keep on ignoring all the time. Last week, there were a lot of people who were trying to ask question about, would we have any extra lecture for input parameter preparation? Unfortunately, no, because that is where the most of the uncertainty lies. People don't know about the Muki information, soil maps are wrong, climate numbers are wrong. And then they say, we have put everything right, and why I'm seeing these peak of flows and I'm not able to simulate these things better, because there is a problem with your input data. And the first place that you should see your input information in SWAT is output.std that Bhumika showed you last time. So that is the first file I would say after running the model that I would see to see if my model is making sense. If not, that means my inputs are somewhere wrong. And last is the parameter uncertainty. Parameter uncertainty can be related to, for example, I have 20,000 kilometers square of the watershed area, and I have, say, 35 soil series. And if I have 35 soil series, the soil series at location A and location B are having the same soil properties. Is it true? Can it be possibly true? May or may not, but in real world, no, there would be changes. But how much changes, I don't know. Could be significant, could be non-significant, but are we trying to model these dynamics? Maybe not, but we are keeping the same parameters for both these location A and B. Can be 100 kilometers or 200 kilometers apart, but that is leading to some kind of uncertainty because we are generalizing the parameters. And sometimes we have to do it when it comes down to a larger landscape, but it is one of the reasons of uncertainty. And while publishing, it is always good to put all these things out there in the paper, a lot of good papers out there. Especially, I would say, read Abbas Puri as much possible. He has really done a good work. And I think I'm left with only 4 more slides, and then we can have a small break. So levels of uncertainty. So there are some kind of uncertainty that we can measure. What basic uncertainty, as I was giving you an example in the very first slide, that 4.2 plus minus 0.2 degrees Celsius, that's an absolute number that I was telling you. So there are certain kind of uncertainty that you can measure statistically, in terms of sampling error, in terms of imprecision of an object or a measurement tool, that can lead to some kind of uncertainty. For example, the rain gauge was not working, and we were not able to record any kind of precipitation for the day. So those things can be quantified statistically, quantitatively, and that is one level of uncertainty. Another is scenario recognition. So in scenarios, what is gonna happen is, first, whenever we are going to use our model for climate change assessments or land use change assessments, we are just putting the possibilities out there. So that has to be very clear with the modeler. So those are not something that's gonna happen, but that is something could happen, but cannot be verified. We are verifying it because of what we have done in the past. We have calibrated our model. It's behaving very good. Model performance R squared 90.9. Yes, we can use it, run it with the future climate scenarios, and boom, you have all the numbers. But be sure those futuristic scenarios are just predictions. They cannot be verified. So level of uncertainty in those is a big question and cannot be measured. So I was talking about the two different extremes spectrums. One is complete ignorance and one is complete determinism. Modeling lies in between these two. It is not possible to have these two extents until and unless you are completely immature, new to the modeling, then definitely you have a lack of information. But theoretically, you might be strong, but eventually, as you get into the model, this immaturishness start getting maturity, but having a complete level of determinism is kind of a very difficult situation. Next is nature of uncertainty. So in the above, the content of the slides was focused on location with the models where the model uncertainty can manifest itself. We also discussed the level of uncertainty as being an expression of the scale of the uncertainty we are faced with. Now, here we are going to talk about the third dimension, which is the nature of the uncertainty. Uncertainty can be epistemic uncertainty, which is due to imperfection of our knowledge, which may be recorded by more research and empirical efforts. For example, like there is a measurement error. You found that your stream flow for one particular day is quite high, but you did not have the precipitation information. You have the precipitation information, but the precipitation was not there. And you check the moisture conditions of the soil with your model outputs, but you are not able to identify what exactly has happened and led to this peak flow. It's a hypothetical situation that I'm putting up, may or may not be relevant, but I'm bringing a context here that there are certain signatures in your input, or there is some kind of inaccuracy in the data, which was unknown or which was blindfolded, and it went into the model and it started producing some irrelevant signatures that we were not expecting. And then there is a kind of a variability, could be due to behavioral variability, societal variability, and new development variability. Right now, we are 36 people out here. I didn't know out of these 36, more than 20, 25 people are working in modeling environment. And they know their subject very well, and they know their algorithm very well. And they always feel like to improve that algorithm, make it 1D, 2D, 3D, and beyond, and to make it more robust and make it more dynamic. So there is always a development taking place over there. And with this development taking place over there, but process-based model like SWAT are talking to each other. If you are making changes to the one algorithm, the outputs of this algorithm is being taken by some other algorithm. So that is uncertainty has been manifested by those new developments. So it can be positive, it can be negative, but those things are there. And then there is community-driven models where all the inputs are coming from your communities, like surveys are happening and other things are happening. So like tillage operations are there, what kind of crops are being grown on the land. So if those questions are there, you're just trusting a few sample of the total population. So that is also leading to some kind of uncertainty. And last, I think this is my last slide, almost last slide. So this is a kind of a matrix I think that every modeler should try to develop. And this is, I have taken it from some paper. I can share that paper with you after the workshop. So we should try to address kind of uncertainty that is coming up because of the context, because of the model input parameters, where it is happening, what level is happening, and what is the nature of the uncertainty, so that even if our model is giving us the wrong answers for the right reason, we would be able to come to know through this matrix. It is a challenge for every modeler to make this thing, but if you're making this up, means if you're putting this box or a matrix out there while you're doing any modeling activity, I assure you there will be least chances that at least your publication or the report that you're putting up with that paper, with that model, is gonna have the least chances of rejection, because you have really documented everything very nicely and accurately. Quantification method, I'm not going to get into it, but what we are going to do today is we are going to use the SWAT-CUP, that is calibration uncertainty predictive tool. We are going to use that as your semi-automated tool to quantify the uncertainty, to calibrate and validate your SWOT model. That is what we are going to use. So in the last workshop, I was having question that SWAT-CUP is now licensed, what to do. Even if SWAT-CUP is a licensed version, there are a lot of R packages that you can use. There are a lot of Python libraries that you can use. And I would say don't become too fancy. Don't think to become fancy when you are measuring your uncertainty. Simply having the fundamentalism of what we have discussed in this presentation today. If you are just developing that matrix, somehow you're quantifying your uncertainty, and you may not need the SWOT-CUP, but SWOT-CUP is something everybody demanded for, and we will be doing a hands-on practice on SWOT-CUP today. And this is all from my presentation. So with this, we'll take a 5 minutes to 7 minutes break here, and we'll reconvene in another 6 minutes as per my watch. And then we will do a hands-on practice on SWOT-CUP. Till then, I'll try to address the questions in the chat if there are any,
Yes.
or if not, please unmute yourself, and I'm happy to answer your questions.
Yeah, thank you very much, Dr. Sushant. So there is a one file missing in your the shared G drive.
Okay, one file missing.
Yeah, there is only two files. If I am correct.
Oh, no, there should be one zipped file also. Let me share it again. Okay. So I have put the link again. So I'll show you how it should look like. So there are 3 files. So this is zip file, and these are one PDF and one PowerPoint.
No, still there is only two files. Your SWAT-CUP 5.6 zip file is missing.
It's missing. So let
Yes.
me share this
Again.
file alone.
Permission.
I think. Oh, sorry. Six zip is public. I got it from SWAT-CUP Google group, so I consider it as public, but the most recent versions are not. So you have to be cautious about it. Permission. I haven't received any email for permissions. How can uncertainty be reduced since it's on every step during the modeling process? So that is where the question comes in, that what kind of uncertainty, first of all? So uncertain, since you're modeling a system, uncertainty will be there, but what kind of uncertainty can you reduce? So definitely you can try to reduce as much error possible from your input uncertainty. So you must be very well aware of what the model is taking in as inputs, especially the weather parameters, management properties, soil properties. So those things I would highly recommend that you should be very careful about. So Thomas, I did not receive a request for permission to access it. Are people able to access it? Not listed in the given link. Wow.
Not yet, yes.
Anyone with the link should be edited. Just give me a second. I'll use some other way.
I'm trying to send by the another G drive. Let me try again. Yeah.
I'm putting it on OneDrive as well.
Yeah.
Oh, Thomas is saying it says it is in violation of Google terms. Maybe because it's a viewer, I cannot make changes to the editorship. Thomas, I'm trying another way around. Just wait. Sidrati, you are right. We can use that one, but the one which I gave you is not tied to a license. So that would help us to do a hands-on practice. So the one which you shared needs a license.
Yeah, just share, sorry, just share the Google Drive. One can try, please. Yes, it's downloadable. So please try this new link.
So Dr. Patel, I am not going to take data preparation for SWAT-CUP, but I will be running the entire SWAT-CUP once. I'll be talking about how you can prepare it, but I will not be spending a lot of time on it. But if you would have specific questions, I would be happy to answer. Okay, so since everybody is able to access the files, since I'm going to begin from scratch with you all. So this is how your folder should look like. So you should be having this folder. And then you have the application installed in. So let's install SWAT-CUP on our machines. Okay. So can I get some thumbs up if you guys are able to install SWAT-CUP on your machines? So we are 41 people out here, at least 5 or 10. Thank you. Bhumika did, Musahami did, Aris Lingaraja. Right. 5 more so that I can begin. Awesome. So Peter is asking, what's the difference between the licensed SWAT-CUP and non-licensed in terms of operation? So Peter, the licensed version of SWAT-CUP has the parallel computing ability. It has even more objective functions that what I'm going to talk about today. It is even more robust. So what I'm going to talk today is the skeleton. I should say 60 to 70% of the basic SWAT-CUP, but if you're looking to run something very big, answering multiple questions, having multi-site calibration kind of question or multi-objective function, then you definitely should go for licensed SWAT-CUP, not the one which I just shared. which SWAT cup is preferable and why? Berihun, I just answered this question. It depends on if you are looking for more complex calibration and validation, running roughly around 40 or 50 different parameters. Definitely, licensed version is more preferable. I would definitely go in for license, but just for the demonstration of this workshop, I found this something long back on SWAT Cup Google Groups. So I thought this is something public and I can use it. And I don't see no why. So 3 more yeses, please. One, 2 more. Great. Awesome. So let's begin. Great. So this is how your screen should look like in the very beginning. If it is so, great. And just a question for everyone, the folder that you just got, does it has this folder external data folder in it or not? Anyone? So when you have unzipped this folder, SWAT-CUP 5.1.6.2, there was an application and there was another folder. Were you able to unlock this folder as well? Means, do you have this folder? Yes, no. Uh-huh. Okay. So I have sent through my university account everything. So can somebody check that if they are able to download the stuff from the share drive? So it should have the folder, the external data. Don't worry, you're not wasting time. Because our purpose is to get this installed on your machine and run the iteration completely once. So we would have time. Don't worry about it. I just want to make sure the people who are attending are the beneficiaries of the data, not everyone. So did somebody setup cannot found the external data? Ashutosh, did you try the new link that I just dropped in the chat box, the SharePoint link? Oh, thank you, Bhumika, for confirmation. So for Bhumika, it is there, the external data. I would really recommend you guys to please reconsider, but no option is there to download. Yes, now we can download from the link. Oops. You guys are editors, so you should be able to download it. Bhumika, were you able to download it or still under question? There's no download option. Wow. Awesome. So Ritesh, you were able to download, Bhumika able to download, Ashutosh. Yes, Bhumika, we will go to step back. So there is download. Awesome. Guys, as you are able to download it and unzip this one. So as you unzip this, there are two folders. Sorry, there's one folder directory with the name external. Oh, you're not able to see my screen. Apologize. Okay, so when you unzip this folder, you have two different files in this folder. One is the directory with the name external data, and another one is SWAT-CUP setup. I would encourage you to just click SWAT-CUP setup and install it. And once installation is done, this screen will open. So I'll wait for another 2 minutes or 5 minutes till the time you guys can unzip the folder and have this application installed on your machines. Unable to get the folder called external data. So, Berihun, I just put the link again if you missed it before. Great, Victor. Awesome. Given that most of the people are having access to the folders, if you have reached to this initial window, it's awesome. So this is how the SWAT-CUP window looks like once it is installed. What we are going to do is we are going to do two different activities with SWAT-CUP, rather three different activities with SWAT-CUP. One is how to set up the SWAT-CUP. And second, we will use the already set up SWAT-CUP model, and we'll see that how the different files are prepared and what different files do. And lastly, what all we can do with the SWAT-CUP. That would be our closing activity for the day. To begin with, since we have this user interface in front of us, so this is the and on the top left is the button with these three boxes, which you need to go up and click, and you need to say new. We are setting up a SWAT-CUP project here. So what SWAT-CUP looks for is just the text in out folder, nothing else. So once your SWAT model is ready, you prepared it with Bhumika last week. So the final product would be in your text in out directory where all the output files are there. And this is where I am taking my pointing my text in out directory to the SWAT-CUP project. Okay, so once you have this new project wizard window open, so it is asking you to browse your text in out directory. So wherever you have that external data folder, go there. Under example projects, there is an example text in out. Again, the first thing that will be available to you on your window as soon as you'll click these three boxes would be to set up a new project. So to set up a new project, you need to have this text in out location. For this text in out location, you need to browse that text in out folder. And in order to browse that text in out folder, the text in out folder is lying wherever your model is. But for today's activity, we are doing it from external data. And under external data, there is a subfolder called example projects. And further in it, there is an example text in out. So I'm opening it. I have given the path. Next. Questions. Okay, so it is saying that SWAT version, I'm using SWAT 2012. Process architecture of my system is 64-bit. And next, what kind of project I'm going to do is I'm going to do SUFI 2. This is where your question comes up that why licensed version? Because you even have more options now. I haven't worked with the licensed version for a long time. It means I'm not working with SWAT-CUP at the moment, but I have heard that most recent versions have even more than 5 different options of projects that you can set up. So for today's activity, we are going to set up the SUFI 2. And next, so I'm going to name my project Syahi 0805-2022. And my project location would be back in Syahi workshop. So once this is all done, what SWAT-CUP will be doing is it will be going back and trying to create a backup for the text in out folder at the backend, which I'll be showing you in just a moment. And this is how it will look like in the user interface, and it's the one which is you are just interacting with. Any questions, concerns till this point? If yes, please raise your hands. There is an option in Zoom nowadays that you can raise your hands and I'll be happy to assist you. So Rama is asking about come again with the project setup. A real quick recap. So go to new, click the next, locate your text in out location, select it. Select the version, select your architect. Next, choose the project. Next, set the location and you're done. Is SUFI the best compared to others? No, I cannot say so, but it's, I should say, more quantifiable. And I think everything is quantifiable in this option, but it's more robust and more frequently used and easy to use, I should say. So this is why I'm going with SUFI 2 option for this workshop, but you can use MCMC, which is from quite an old days. And glue is also an option. I have read papers, I have reviewed papers with the glue. Even glue is something that you can try outside the SWAT-CUP once you understand it. So to answer your question, Sufi is not the best, I should say, but it is one most frequently used. This is why we are using it. Okay, so once we are here, let's begin with the first part of the activity is done, that how to set up the SWAT-CUP project. Now, the second part of this activity is to go through all the files and understand the output of those files. That is the second part of this SWAT-CUP activity, which we'll be doing for next 25-30 minutes. And then lastly, we will be seeing that how we can use SWAT-CUP for land use and managements and climate change studies. Okay, given that, let's begin with calibration inputs. So once you expand this option, so there are multiple options out here. So there's a parameter info file. So there is a description of this file at the bottom left of your screen, and there is a big screen in the middle of your user on your Windows, which is telling you about the basic information about the parameter name, the file name, and the file extension. I will be coming back to this file again in the third part, but for now, you just need to understand this par-in file is taking all the parameters that you want to test or you want to use for sensitivity analysis, you want to use for calibrating your model. So this is where your model comes in. Few mistakes that people do here. You keep on increasing the list of the parameters, but you don't increase the parameters from here. So make sure if you're adding parameters, if you are increasing the lines or anything, make sure you are having all the relevance changes in these boxes as well. So you can see now there is a red cross out here for the reason that there are only 4 and I have asked it for number of parameters of 5. So if I go with 4, that red box closes. How can you add parameter? You can bring add parameter here. Suppose in HIU file, I need to change the soil evaporation coefficient. And I need to bring in, this is red in color for the reason, because as I mentioned, we did not change the number of parameters. In the box, there are 5, but here in this box, it's still 4. Once it's 5, it will turn into green. So you have to be very careful with these small things with the user interface. So this is quite an interactive window that you can play around with. This is called the form view, which is quite easy, but what the SWAT-CUP is studying is this text view. So I don't like user interfaces a lot because if you're running a small model, simple model, user interfaces are awesome because you can really do the stuff quick. But if you're running models which are quite hefty and your machine is not that have not that capacity, I really like to play with the plain flat text files, which is these text views. I'll show you where these text files would be, but for now, the take-home message from this file is all the parameters which you are going to use in your calibration process should be here. And once you have those parameters, there are the 3 different methods that SWAT-CUP allows you to test it. One is relative, another is replacement, and third one is absolute. So relative is 1 plus any number that will be coming out within this range. For example, CN2, let us suppose in our files is the value of curve number is 70. And we are saying by this particular line is change my CN2 in such a way that either it is within the 80% or 120% of 80, or sorry, I said 70, right? So if I have curve number of my particular land unit as 70, let us take some simple numbers. Let us take just 100 for easy maths. So if my curve number is 100, which is stupid assumption, but just for the maths purpose. So this is saying that test my model with the possible iterations, considering any random number between 80 and 120. Right now, my curve number is 100. Take any numbers between 80 and 120. So this is what relative means. 1 plus minus of your numbers out here times your value. So that is relative. Replace is just replacing. For example, my soil coefficient can be just between 0 and 1. Right now it's 0.65. I'll say that take any number between 0 and 1 and just play around and tell me how much my runoff would look like. So replaces, if it chooses 0.8, it will just replace 0.65 by 0.8. And the third one is absolute. I think absolute is something which is just an addition or subtraction factor. To be sure, I have given you guys a SWAT manual in that folder also. Just give me a second and I'll share with you the page number of that folder. Okay. So yeah, so if you go to page number 25 of the PDF that I have shared with you, so it explains everything relevant to par-inf that I have just explained if you need a literature to read. So this is pretty easy and handy high-level English that you can read to understand what I just explained verbally. So there are questions. Okay, so Bhumika is answering. Next is, okay, the other thing in this particular file you need to take care of is the number of simulations. So there are two different things in SWAT-CUP. One is simulation and other is iterations. So there are n number of iterations in m number of simulations. So there will be one simulation, but you can run it for 100 and 200 times, and that within that simulation running is called iterations. And we will see how does it work here in a while. In 5-10 minutes, we will be seeing that this is just one iteration setup that we are setting. And in this iteration setup, we will be running 5 times this particular model with these value changes. So I just need to make change to this replace and save. So the second file is the swedit.define file. So it is telling us which simulation number I should be starting and where I should be ending. Mostly in the initial runs, it is ending number is the same number of simulations that you are putting in here in the first file. So it should be starting from 1 to 5. Once your model is calibrated, you have the number of the simulation that is giving you the best result. We will bring that number here, and I'll show you at the end what I meant by this. Third is the file.cio. This is exactly the same file that was there in your folder. You remember from the last workshop when Bhumika mentioned about number of skip years, for how many years do you want to run, what kind of input output do you want to print. So that is your file.cio. So this is exactly being taken from your model as it is. So these are absolute SWAT values. So you don't have to do anything in this particular file. So this is a kind of a database for SWAT-CUP. It has all the SWAT parameters that is related to files and explanation and their lower and the maximum range. But for your watershed, there are chances that, say, not the coefficients, let us take some different number. For example, in this soil chemistry file, so this .chm is the soil file where you have these initial concentrations. So say in this initial nitrate concentration in the soil layer, you want to test, you say that your location is not having 0 to 100, but your location is having 0 to 400. You may make change here, and given the changes here, you can put the minimum maximum accordingly. Caution, if you are not gonna make change in this file, suppose if it's only 100 out here, if it's just 100 out here, and in par info, you bring that CHM number and you say that, I'm just putting a hypothetical scenario here, 200, and you will run the whole SWAT-CUP thing. It will just not show you any kind of error, but it will not produce any results either. So that was because in absolute SWAT values, the value range was 0 to 100, and SWAT-CUP was not able to consider any number beyond 100. But what this thing is doing, it is running a random generator number kind of thing, and it will produce some number which will be more than 100. And once a simulation with ESCO of 100 or nitrate number that we were talking about, if that would go above 100, it will not know what to do with it, because in absolute SWAT values, the maximum number was 100, but you went beyond that limit. So no big changes to be done in this absolute SWAT values until and unless you are sure what you need to do. This is where the second major difference happens, that why to use the licensed version of SWAT-CUP is for the reason because they keep on updating this database, and with SWAT Plus, with more new modifications in SWAT 2012, they have the new database that you keep on changing. So licensed version makes sure that you have all the parameters in here. So recap, par info contains all the files, contain all the parameters in the respective files that you can either make relative change to, you can replace the change, or you can make the absolute change to it. Those will be here. And for this iteration, you define how many number of simulations should be there. Recommended simulation are, if there are 5 parameters, means with my experience, I would say 100 simulations for each parameter. So be very careful choosing the parameters. You cannot have 40, 50 parameters because you don't know what is sensitive, what is not sensitive for your watershed. So be careful, be aware that what research question are you answering and what parameters can be impacting it. So thumb rule for me is, if there's a 1 parameter, 100 simulations. If there are 5 parameters, there's 500 simulations for iteration. But for today's workshop, we'll just have the 5 simulations. Let's delete this one. Means if you want to delete, you can delete this one too. And the second was the definition, where we are defining the beginning and the ending of the simulation number. Third is your file CIO, which is exactly that is taken from the model. You can make changes to this file, but if you make changes to this file, your model will crash. So prefer not to play around with this file. So calibration inputs is done here. No. Okay. Now comes the question, observe. So in this observation file, they are asking you against what numbers you want to calibrate your model. Before you can do the validation after that. Okay, so this is asking you against what numbers do you want to calibrate your model. So we have three different options. You can calibrate your model for the reach. You can calibrate your model for a HRU, which is the smallest and the finest spatial resolution of the SWAT, and at the sub-basin level. So mostly at reach, you can have your stream flow and other basic parameters that is there in the output.rch file. So once you select this reach, this unhighlighted version will become active. So if you can see that as soon as I click on RCH, this version becomes active. For example, if I touch HRU, this becomes active. If I click sub, this one becomes active. I can deactivate them as well. So for now, just giving you a sense that what our observed RCH file looks like. Observed RCH file will ask you how many variables do you have the value for. So in this case, what is this file telling you is SWAT-CUP, I'm giving you values for 4 different variables. So flow out one is the stream flow number, and there are 141 values which are there. And I'm starting from the month 1, 1990, and I'm going to 2001. So there are 141 values from the first reach. Then I have, again, the second variable is also the flow out. The third variable is also the flow out, and the fourth variable is nitrate out. But the difference you can see here is, though it doesn't matter what name do you give, but you should be very careful about what exactly are you doing. So this thing is telling SWAT-CUP is, I am giving you this file, which will have 121 values of the flow numbers. Few things to be very careful about. It is not necessary that the numbers has to start from 1. If you have a missing month in between, you can skip that, but make sure the order should remain the same. For example, this is not starting from January of 1990. This is starting from November of 1990, whereas this one was starting from January of 1990. This is why it was 1 here, but here the numbers are not starting from 1, but starting from 11. If you see at the bottom, the total number is going to 131, but here it is saying 121, because that 131 is a serial number in the order, and this 121 is the total number of values that we are giving. So you have to be a bit careful what numbers are going in and out. And since I have given the 4 variables, I have given the 4 different values. So this is 1 variable, flow out 1, flow out 3, flow out 7, and nitrate 7. So what this 1 is representing, it is for reach 1, and flow out 3 is for the reach 3, flow out 7 is for the flow out 7, and nitrate 7 is for the nitrate 7. But as I said, whatever you are going to name it here, it doesn't matter, because it is just the text it is going to pull out the information from. So, but just to make it more user and self-explanatory, that they may name it as such. So this is the information the user provides if you have data for the specific reaches. Now, this third button is for the extraction. What extraction is going to do is, so you remember I told you that you can name anything. So extraction is, the first is variable file reach.txt is going to extract those numbers, strings from here. Whatever you're going to name this one, it is going to pull this and put a .txt string at the back. So these files will be created, and these files will have information of the parameters or the variables that you will be giving it to. For example, flowout1.txt file, which I'll be showing you in the model folder, that would have 141 lines in the same format for the monthly flow ranging from January of 1990 to 2001, September of 2001. So there will be 4 different files because there were 4 different variables. And then Sufi extract reach.define. So this is going to tell us what information we need to extract from the model. So the first line is telling, since we are calibrating our model at the reach level, go to the output.reach file. The number of variables, we are talking about the 2 variables. Though we have given the 4 variable values, but actually there were 2 variables only, flow and the nitrates. So this is why here we are just having 2 variables. In output.reach file, which I can show you right away. If I have output.reach here, no. External data, utility. Here. So your output.rch, how does it look like? Oh, it is also not run. I should have some output.rch. Sorry, guys. No, but I'll show you once we'll run the model. So in output.rch, the 7th column is basically your flow out column, and 18th column in that file is basically your nitrate column. So what I can show you is docs, chapter 32. Okay. So yeah, this is the output.rch file. And if you see here, 1, 2, 3, 4, 5, 6, this is 6, but there are more file columns there. So this is the flow out would be the 7th number column, and nitrate out is the 18th number column. So this is what we are calling here. And in our model, there are total number of 20 reaches. So here it would be 20 total number of reaches. We are using 3 reaches because if you remember, that was flow out 1, flow out 3, flow out 7. So there are 3 reaches that we are using. So we have put the input 3 and we have called those reaches. But for nitrates, we have only 1 reach, which was reach number 7. And we are doing its calibration for entire 1990 to 2001 period. And what we have provided is the monthly information. So we are putting 2 here. And the important part is understanding the objective function portion. So this is where the question comes in. Observe variables, definitely we are having 4 variables on the multiple sites, but actually we are just doing the 2, which is flow and the nitrates. But we are providing the 4 different variable values. Objective function, we have an option for these 9 different variables. And another advantage of licensed SWAT-CUP is we will be having even more. I think now they have 11 to 14 objective function types. So here they are using the RSR. The description of each objective function is in the manual that I shared with you. And now it comes the weight of each variable. So this file looks similar to the observe.reach file, but with the difference that when you're calibrating it with the flow, do you want to consider the base flow or not? If you want to consider the base flow, do you want to make it static or dynamic? So a lot of questions and opportunities here in SWAT-CUP that you have. Currently, we are not doing any base flow separation or base flow calibration. So we are not having any column for it, or we are not putting anything here. But if you want to put dynamic base flow against this 1.38, there will be another column that will be having values for the base flow numbers. And correspondingly, these things will also be changed. So like this is asking for your dynamic flow separation, not considered if -1. If 1, the values should be added into the 4th column after the observation. That is what I was telling you, that if we put just 1 over here, we need to add a 3rd column. 4th column to give the value of the base flow. So since there were 4 variables, we will prepare the same files for flowout 1, flowout 7, flowout 3, and same for the nitrates. And this is how the observe.txt file looks like. And variable file name would be similar to what the variable file reach.txt looks like. So 4 variables, 4 files should be there. Since we are just running for the workshop purpose, we have the values, we have the dummy model, but in case you don't have the model, don't have the data, so there is a no observation files as well. But before using this no observation, my caution here would be, please make sure how far your model is looking from a reality. That is what you have to inspect even before using SWAT-CUP. So in that case, you can use the no observation values, and how to use these no observation values is again in the manual I shared with you. If time permits, we will be doing some of this no observation part, but if not, I will be touching the other applications of SWAT-CUP. So that being said, we have all the inputs ready to go into the SWAT-CUP. So we have saved all the files. I do not want to change anything. No, this can't be saved. So this is where we feel like our model is good to go. So we'll go to the calibrate per option here. We'll run the pre-batch, and I'll tell you what this pre-batch is doing. I'm just first running everything. So yes, I want to run Sufi. And once it is done, I'll run the batch process. Here it is going to make changes to my files, run the model. It is going to generate the numbers. So I have asked it for 5 simulations. So if you see here, this is simulation number 4, simulation number 5. So this is where my model will end. So process is ended. And then post-batch is just going to compare my one-to-one numbers, the monthly files that I have provided it. So it will create at the back end, it will create a one-to-one comparison and generate the objective function for me. And if my objective function is falling within the limits, it will produce error. It will produce the result. If not, it will generate errors. So once everything was done, so if you see, it is asking me save this iteration. Let us save this iteration and see what it is gonna say to us. So this is where the iteration history is, and I'm gonna go into iteration 1, and I'm gonna look the 95 PPU plots. So 95 PPU plots is 95% prediction uncertainty. So these green plots is basically with all these 5 simulations, what is the max and the minimum that is generated out of those 5 simulations is plot within this band. And blue lines is the observed information I shared, and the red line is showing the best estimation, means what SWAT-CUP has been able to generate to these 5 simulations. So this is why it is not recommended 5 simulations. Less simulations are always good to just check few things here and there to understand your model better. But as I said, once you are very confident with your baseline model, it would be good to have a thumb rule of 1 parameter equal to 100 simulations. That is how I would go for at the beginning. So this is really showing that our results are really not that good after the 5 simulations. The model is underestimating the numbers. So you can do a lot of things with this particular user interface. You can play around the chart layouts. What kind of charts do you want to draw? What do you want to put? Even this data range, it's dynamic in nature. You can zoom in, zoom out. Functionality is also there in SWAT-CUP. Besides, you have all the variables as well. So we have flow out 1, flow out 3, flow out 7, nitrate out 7. This is behavioral simulations. So which I'll dive in a bit what exactly this is, but our prime concern is these 4 charts, record 1, 2, and 3, and 4. So this is 95 PPU plots, and then we have these dotty plots. So these dotty plots are basically plots that show us the sensitivity for the each parameter. So if you see here, I made change to the curve number that was relative with -1 and +1. So if you see here, as soon as it goes to this number, my objective function is changing drastically. So that means curve number is really playing a quite higher significant role while defining my flow for the outputs. Whereas if we say that this alpha be a base flow number coefficient, how it is behaving when it was approximately 0.2, not too drastic changes outseen here, but still sensitive. So this is gonna tell you, but since these are just 5 different simulations, it's very unclear to say which ones are playing an important role or not. But clearly we have signature out here in CN2 and BF. But in case of groundwater QMN, it's not very well clear because it's showing zigzag signature. Even if it is required for the further calibration or not, you can take that out. If you are not understanding the dotty plots, there are summary stats and the best parameter chart. There are other files that you can definitely look in for to understand what exactly these files, these parameter mean. I'll show you in a second. So this is the best parameter set that we have. So goal type was KGE. A number of simulations we ran were 5 in this iteration, and it is saying that the best simulation number was 5. And it is telling us that it ran the relative value of -0.2 to 0.2, and the best worked out is 0.08. Hypothetically, example, if my curve number was 100, it ran between numbers between 80 and 120, and it is telling that 108 was the best fitted value. Same with the alpha B if it is with replacement. So anything between 0 and 1, it is saying that 0.3 played a better role. So this is how to interpret these values. And then comes the turn of best simulation. So this is 1-to-1 match that they have generated those 95 PPU plots from. So these blue and red lines are plotted from here. So you can just copy this. If you're not liking the plot they have made, you can just copy this in Excel or any software that you want to work with and can generate your own plots. Goal.txt, the same thing, number of parameters, it will give you the same information. But this goal.txt is showing you or is telling you in each simulation, what values have they considered? Since it's a random generator at the back end that is generating the numbers. So in the first simulation, the curve number was 92. means if I'm considering 100 as a curve number for my study, which is not an ideal example, but just for the math's sake. Then alpha BF, they chose 0.7, and all of these are randomly generated simulations. So this is telling you that in each simulation, what has been run. Okay, and the new parameters set. So initially, if you see, here we are running it with -0.2 to 0.2, and after this iteration, it is telling me that we can further reduce down our range to this, whereas I can see this has magnified the range for CN2. But for BF, base flow parameter, the initial value was 0 to 1, whereas it is recommending us to go even less than 0, which is -0.5. So always remember that this is driven from a statistical model. This is not any physics. There's no physics behind these numbers. So groundwater delay with the value of -188, is it visible? Can we have it? No. So would it be required here? Because we are just putting the replacement. So if you don't think before just copying these numbers from here and putting back again in this file and rerunning it for the second iteration, it will be completely useless. So you be careful that whether these numbers are even making sense or not. So ideally what it is doing is it is even creating a narrower range that you can use with after every iteration. But that narrow range is just defined statistically with so you have to be careful taking those numbers. And last is the summary stats. So though we have chosen just the KGE, but it is giving us the summary stats for everything out here. So starting from P factor, R factor, I'll explain you what P factor, R factor is, but this is everything that is there. But we specifically asked SWAT-CUP to just consider KGE and maximize it. Next is the sensitivity analysis. That dotty plots that I was showing was a kind of a sensitivity analysis. There are two options of sensitivity analysis. One is the global sensitivity, another is one at a time sensitivity. So global sensitivity, consider it that you are having all the 10 parameters running together for a model, and you're having an output, and you are saying that what is the impact of all these 10 parameters together on a simulation. That would be something called a global sensitivity. One at a time would be out of those 10, I would run each one variable separately and would see the impact, that how curve number individually is impacting, how my soil coefficient is impacting, how my alpha base flow factor is impacting. So those numbers are the way I will be doing one by one, making changes would be a one at a time sensitivity. I think for global sensitivity, they need 6 observations are required and only 5 were provided. So there is a minimum number of simulations that you need to run. I think ideally it would be good if you have 500 or 600 simulations. Global sensitivity is good at that part, but one at a time can be done here, and I need to show you p-value. Okay, so this is how it ran. So the flow out one at a time. So this is the value for, there were 4 variables that we took, which was CN2. Where is that chart? Yeah. So it ran with the value of -0.8. It ran with no change. It increased the CN2 by 16%, reducing by 16%, increased by 8%. and if there is no change. So this is how this graph looks like. That suppose if we take this red line, so it is showing that increasing CN2 by 16% is, this is how my flow will be impacted if I increase my curve number by 16%, making sure that no other component is changing, no other parameter is changing. So this is where it is showing record 1 of 4, record 2 of 4, record 3, and record 4, making changes to the parameters out here. So ideally, I would recommend you to go for both the global sensitivity and the one at a time sensitivity. Global sensitivity provides you the t value and the p value, which is even more robust to determine that which variables are making having more impact on the study. Okay, so that being said, this is just a general review of how SWAT-CUP works, how the files look like, and how we can play around with SWAT-CUP. But there's a lot with the SWAT-CUP that we can do that we will take just in 5 minutes break, and we'll come back and we'll deal what we can do further with SWAT-CUP. Till then, questions, concerns, happy to answer. So Peter asked a question, which I think Bhumika has addressed almost all the questions. Since I have just 5 minutes, I can add beyond what Bhumika mentioned. How do you know which parameter is key for the calibration? As Bhumika very clearly mentioned that there are literature available for major research questions that which parameters impact what kind of processes. So you can definitely use those parameters as the ground point. And if you know which particular processes are very important for your simulation, I would say go back to theoretical documentation at swat.tmu.edu and look in their document, and you will find some variables in that would be sensitive, that may be sensitive, and you can use those for the calibration purpose. Is it possible to validate the model as well? Yes. So this is what we do. We try to do the time split analysis. Time split analysis is, in modern machine learning term, we say that test and train the model, or in our hydrologic term, we say that calibrate and validate the model. So if you are running models, say from 1990 to 2001, I would say use till 1990 to 95 or 96 more. Give calibration as much information possible. For example, if possible, try to decide on calibration timeline, which has the variability of both the high flows, low flows, and the normal average flow conditions, so that your model is sensitive to both the extreme ends, so that it performs better in the validation. Not better, but at least it can pick up, it can be tested better during the validation part. If you are just giving the high peak numbers during the calibration portion, then your model will be start showing you off numbers in the validation, and you will be surprised that, wow, my calibration numbers were 0.8, 0.9, and my validation is just 0.3. Why? Because you overtrained the model with the high peak numbers or the low peak numbers or average numbers, and it was not sensitive to the other kind of conditions. So be very careful what you are giving it to calibrate, and based on that, use the same set of parameters, and on the remaining timeline, you can validate your model. Which format? I would highly recommend everyone that if you're running SWAT, run it at the daily time step. Means even if the model is extensive enough, I understand computationally it requires a lot power, but run it at the daily time step, and manually you can aggregate it at monthly and yearly time step. I don't know, I'm personally biased towards it. And in case of calibration, especially with hydrologic information, I prefer to do it daily if it's the flow condition, but if it's ET or water quality conditions or some other important variable which is seasonally dynamic in nature, I would do monthly. I would not go for yearly until and unless it's a very huge ungauged watershed with so many research questions. Then I would like to see annual changes if you're working on some countrywide stuff. What's the estimated time 10 parameters can take depending on your recommended number of simulation? Depends on your model size. It will be almost, you can say, if your model takes 3 hours to run, SWAT-CUP will take 4 hours to run, the same thing. So just consider that there will be one additional layer. And if you are having a very coarser resolution model, the one which we are using for our workshop, it's quite a big watershed, but having very small number of sub-bays and sub-watersheds, it was pretty quick. So it all depends how you have set up your model. How can we get exact value of the parameters after calibration in case of CN? We get relative change if we want to collect the calibration parameter up and run our Q-SWAT model. Lingaraj, I'm going to talk about it in the remaining time just now. So I think I will not be able to finish everything from SWAT-CUP today. We will be taking some portion of SWAT-CUP tomorrow, but I'll be answering Lingaraja's question, and that is what was there on my third section of the SWAT-CUP. And we'll take the SWAT-CUP again tomorrow, and tomorrow we will be studying more about how to use your text in out folder and read some files, plot some more charts out of SWAT-CUP, and see what we can do manually, which is not recommended. But if you know your watershed very well, sometimes manual calibration is even more advantageous. And I'll show you just a glimpse of how the source code of SWAT looks like, which we are not gonna deal with in this workshop curriculum, but that is where your all algorithm resides and how you can make changes to the source code as per your study area, your needs, and by that we will conclude our workshop. Okay, coming back to SWAT-CUP again. So now we have our best simulation done. So our best simulation was here. So it is saying that the best simulation number was 5. So Lingaraja, the thing is, and others, the best part of SWAT-CUP is you don't have to worry how to make the changes. What you can just do is go here and starting simulation number is 5 and ending simulation number is 5, because that is your best simulation. That is all you need to do. Save and run the batch, the second one. Boom. And where you have your model, this particular model files will have all the changes automatically incorporated in it once you have that change done. Again, before I answer question for Peter, what I did was I've looked into my saved iteration and I saw that they mentioned that the best simulation of all the 5 simulation was simulation number 5. Without changing anything in my calibration inputs, the only thing that I changed was going into this .def file in calibration inputs. I put the initial number 5 and the ending number 5. I went to calibrate portion. I did not execute all. I just ran Sufi to run batch, and it will have everything done for you. Why I did not run everything? Because this pre-batch is done to generate the suite of the parameters like here. This. So pre-batch is doing this work. Post-batch is doing this work. So what we just needed was run batch process. So this is what we needed. So this is why I just ran 1 out of the 3. I ran it, and wherever you have your folder, so all the output files are here, output.std, output.rch, whatever you want. So this would have all the changes incorporated to it automatically. So this is the magic of SWAT-CUP. But what you can do is you can bring the things out of the SWAT-CUP as well, which is for example, if I go to this file, so curve number is an HIU parameter. So if you're working to, if you're focused on just one HIU or 2 HIUs, not all HIUs, you can go to that individual HIU number. Sorry, it's a management, no, not this one. So it's a management variable. You can go to that specific HIU file. So I just need to make sure that HIU2 of the sub-basin 19 is the one which I'm calibrating it with. So I can make changes to the curve number here. So the best suggested value was 8% increase to this 90. Suppose it's 94. I'll make changes to this file, save it, and run my model again. So this is how you can do it externally. There are hundreds of different ways to do it, but this is recommended only when you have the values, you're concentrating on specific HIUs. But SWAT-CUP can do that also, which we'll be taking tomorrow in our class. Peter, we will be taking the manual calibration tomorrow as well, because the concern of the people was this only, that SWAT-CUP is licensed what to do. Okay, before we close our workshop today, the only recap that I have for today is just one chart I need to show you guys. I think I have it in my drive. So there is one flowchart that you should definitely be well versed with while working with SWAT-CUP, and it's this one. So what we did was we gave it parameter values, the CN2, relative, absolute, or replace. And then there is this SWAT edit executable application within the SWAT-CUP. What it does is it takes those value ranges and it starts generating the parameter values. So as we saw that we ran it for 5 different simulations, and for every different simulation, the numbers were different for all the 5 variables we chose. It creates the new inputs, and there is a SWAT executable inside the folder, which runs the SWAT. SWAT generates the output, and this application SWAT extract the outputs from that SWAT output and check against our goal function. And the goal objective function is basically these 5 different kind of optimization techniques that SWAT-CUP gives us, and what we use for SUFI2. This is very big picture what SWAT-CUP does, and what exactly SUFI2 is doing is size. Yep. So this is doing the same thing. We are generating the in text file, giving all the values of the parameters that we want to test based on Latin hypercube sampling. This application is generating the new parameter set values, which SWAT edit application is taking in and making changes to the SWAT files. And as the changes are made to the SWAT files, SWAT is run, outputs are generated, whatever values we are giving, like the flow that was from column number 7 and the nitrates that was from column number 8 from output.reach file. So this application extract_reach.exe is pulling out those column numbers from SWAT simulation. Observe.txt, we are giving the observe numbers. It is comparing those, and this goal function is generating the goal of the objective function, that if you're selecting KGE, my KGE should be more than 0.5 for that specific variable, and the goal text is generated. And if everything is within the permissible limits, it is for each iteration, the 95 prediction this uncertainty curve is generated, that PPU curve is generated. If calibration criteria is satisfied, it stops. And if not, the number of simulations keep on running in the loop. So this is the brief about SWAT-CUP, and we'll spend another hour tomorrow learning more about the SWAT-CUP, what else we can do, how we can do the climate change study, land use change study, and other things with SWAT-CUP. And as I said, we'll do some kind of manual calibration. We'll do some kind of reading the outputs and making sense out of it, and how, as a hydrologist, we should be careful about a few things. That will be all for today. We are already 1 minute past the desired time. I will not keep you holding. Yeah, any questions, concerns? I will be here for another 5 minutes or so if you want. Otherwise, I would be happy to take any questions. My email address, I'll put it in the chat. If you have any specific questions regarding your thesis or concern, let me know. Yeah, thank you guys.